Hi everyone, nice to have you back. In this video, I would like to go over another example to give you more practice with the concepts of sensitivity analysis. I made an earlier video in which I go over, the whole idea of how to read Excel's sensitivity report in detail. That would be targeted at people who had never seen those concepts before. If that's your case, don't let this be your first sensitivity analysis video. You should watch the other one first. I'm going to leave a link to that in the description of this video and also for you to click up here in the corner. So this should be a second video at least for you to watch after that one. But if you're already familiar with those concepts of shadow prices and reduced costs and allowable increases and decreases, this video is for you, just to practice that a little bit more and gain more confidence in using those tables. All right, here's the story. This is an employee scheduling example. We also have a video on just modeling and solving this problem itself without worrying about sensitivity. If that's what you're interested in, go find that video. And in this case, I'm going to assume we understand what the problem is, and the focus really is on the sensitivity. So this is a restaurant that wants to staff each day of the week, right? And they have requirements. So for every day, you know how many people, how many, let's say, servers you have to have on duty. And the way that people work their weeks in this restaurant is that they do 5 consecutive days and 2 days off. So if you go here, we make a variable for each of the possible work weeks in this restaurant. So x1 is how many people work the week this way. They are on duty Monday through Friday and they're off duty Saturday, Sunday. x2 is how many people work the week this way. That is, they are on duty Tuesday through Saturday and they are off Monday, Sunday. And if you keep, rolling this 5 number one, the 5 consecutive on-duty days, you keep rolling them down like this, and they kind of rotate around and start to appear on the other side, you get 7 different work weeks possible. So for any given day, what you have here is, well, the sum of the people who are on duty that day, in this case Monday, has to be at least how many people I need on Monday. And initially, the objective function is just to say I would like to hire as few people as possible because they cost money. So I minimize the total number of people hired, which is just the sum of the x variables. Great. If we were to just solve this problem and get the sensitivity report, and here I have everything set up, we're not going to go over this now. So when we get that solver window back, before clicking OK, you click Sensitivity to get the report. Then you click OK. The report will appear. Here it is. So now we're going to use these tables to answer some what-if questions. Let me make this a little bigger. Okay. Let's go to the questions then. Here we go. If you did not have access to this sheet here, right, where the answer is, but I only gave you this one, could you tell me what is the current total number of workers needed to staff the place? Well, to find that out, you go to the final, so this is a question about your variable, so you go to the top table, find the final value column. What that column gives you is the final answer, what the optimal solution was, that is the value for each of your variables. If we recall, the objective we are minimizing is how many people we hire, which is basically the sum of the values of all the x variables. So if you wanted to know that, you could just sum these values, right? And that's your 22, which of course will match the 22 here. So we are currently hiring 22 people to staff the restaurant. Question B. Due to a special offer, 3 caipirinhas for the price of 1. Demand on Thursdays increases. So currently, we are asking for Thursday, we are asking for 16 servers on duty, right? And because demand increased, you now believe that you need 18 workers on duty on Thursday, as opposed to your current 16. What would be the effect of this change on the total number of workers needed to staff the restaurant? And remember, the total number of workers staffing the restaurant is our objective function, right? So let's take a look. So if I were to increase this number here from 16 to 18, how would that affect the current optimal value, which is 22? Well, we'll look at the allowable increase because we're considering an increase. The allowable is 3. That means that we can use the shadow price of this constraint to calculate the result of the change. Well, the shadow price is 0, which means the effect on the number 22 would be a plus 2, because it's the increase of 2, times 0, which is 0. That is, I would not change this number, meaning I would still only need 22 people to staff the restaurant. However, if I were to ask you, will the solution, right, because this is the value of the solution, we concluded that the value of the solution will not change. I still only need 22 workers in total. But will the solution itself change? Well, let's see. In the current solution, how many folks are we staffing for Thursday? We're staffing the bare minimum 16. So if I were to change this to 18, the current answer doesn't cut it. However, the fact that the shadow price is 0 for an increase of 2 simply means that there is a way to reshuffle these same 22 workers so that I would end up with an 18 scheduled workers on Thursday, while at the same time still fulfilling all of the requirements of the other 6 days of the week. This is not telling me how to do that reshuffle. For that, I would have to resolve. It's just telling me that if you need to raise this number by 2, you don't have to worry about hiring more people. You can make do with the 22 people that you have today. All right? Great. Part C. Now let's assume that demands on Fridays now goes down, right? Maybe a competitor restaurant opened near us. So instead of the current 19 that we're requiring for Friday, right? There's 19 here. We now only need 16. What would be the effect on the total number of workers needed to staff the restaurant? Okay, let's go to Friday. The change in the constraint. So I look in the bottom table. This is the number that I'm changing. I want to lower it by 3. Is that allowable? Yes. So the impact to the objective value, which for us in this case right now is people, right? The objective value now is currently 22 people. The impact will be the amount of the change is a minus 3, right? Times the shadow price. The shadow price is a third. So minus 3 times a third is minus 1. That means my objective will be 21 people. So the result here is if you only needed 16 workers on duty on Fridays instead of 19, you could make do with a staff of 21 workers instead of 22. Okay, great. Let's go to the next. Okay, so now they're asking us to make a little change to the problem. If we look at our objective right now, it's basically the sum of all the x variables. Now imagine that I had I wanted to make this objective a dollar valued objective, and so I could have a row here called the salaries of the employees. Let's say the weekly salaries, and let's say originally everybody made $1,000. So this one means how many $1,000 do they make per week? I'm going to say 1. So right now, let's say if everybody made $1,000 a week, right? I could make a total salary cell, right? By doing a sum product of how many people are working each day, or each work week type, right? Each job type, times the salary that each job gets paid, right? So this expression is 1 times x1 plus 1 times x2 because these are how many $1,000 they make. Well, notice that 1 times x1 plus 1 times x2 is the same thing as x1 plus x2 plus x3, etc., which is the same thing as this number, right? So it's not a surprise that that's also 22. But under this new interpretation of the objective function, this number now is how much money am I spending to pay my people? And the answer is $22,000, right? So the current sensitivity report would be still the same if I were to resolve this problem, because these two expressions are the same thing. It's 1 times every variable, right? But for the following questions, I want to interpret these ones here as how many thousands of dollars does the person that works that job gets paid, right? That's what I want to use. Perfect. So we just reinterpreted the numbers, but the sensitivity report is the same because we did not change the numbers. We just changed how we see the numbers. Excellent. So question D. Workers have complained that Schedule 6, right, the work week type 6, is the least desirable. Well, let's take a look at that. Work week type 6. Okay, here's why they complain. You are working, right, Saturday and Sundays. So your weekend is gone. You can't really, enjoy that. And the Friday, which is one of the days that people give a lot of tips because everybody's going out to the bar to celebrate the end of the work week, you're off, so you're not making those nice tips. That could be a reason. So management is considering increasing the wages of those workers because they think, oh, this is unfair. So they're debating perhaps we should pay these folks instead of $1,000, $1,100. Which would translate here into making this a 1.1, right? The question then is, if we did this, would this change the optimal solution? Meaning, would we reallocate these people? And also the other question, part of the question is, what would be the effect of making this change here, making this a 1.1, into the overall expense we have with salaries? Well, let's take a look. The number we're considering changing is the objective coefficient of a variable. That is the number that multiplies a variable in the objective function. And the one we're considering changing is this one. The change we're considering is an increase of, because we're thinking thousands of dollars, is an increase of 0.1, right? Not of 100. Is that allowed? Well, yes, it is, because the allowable is 0.5. Great. Which means within the allowable means the current solution remains optimal. So to answer the first half of the question, the optimal solution would not change if I were to change this number to a 1.1, but would we still be spending $22,000 to pay these folks? The answer is no, because now I have 3 folks who each make an extra $100. So my new expense with wages would be the current one plus $100 times 3. So I would now spend $22,300. Okay? Great. And this is like a counterpart of that question. Schedule 2, on the other hand, is very desirable. Let's take a look. Schedule 2. Oh yeah, because you have Sundays off, which is nice to rest, and you're on duty Friday and Saturday, which perhaps are the days when people go out and spend lots of money at restaurants, and then you get nice tips. So because of that, management is considering decreasing the fixed salary of these employees because they seem to be making more in tips. And they're considering decreasing it from 1,000 per week to 900 per week. Or in this case, they're saying per month. It doesn't matter. So the question is, again, two-part. Would this change the optimal solution? And secondly, what would be the effect on the total expense with wages? So this is now we're considering changing this number down, right, by 0.1, right, from 1 to 0.9 or $900. Is that okay? Well, the allowable decrease is 0. So at this point, we're going to say that the optimal solution would not remain the same. And because of that, I can't really answer the other part of the question because I don't know what number would end up here. Now, just for the sake of the exercise, if I had asked this question of the shift or work week type 1 people, as in, what if I was considering decreasing the salary of these folks by $100? Well, that's okay because the allowable decrease is 1 and I want to decrease by 0.1, right? 0.1 of 1,000, that's my $100. So current solution would remain the same. What about my expense with wages? Well, it would go down by $100. How many times? Well, there are 4 people who work that job. So I would save $100 4 times, meaning $400. So the new total expense with wages would be $21,600. Okay, great. And last question. Management is considering introducing a new schedule or work week because right now we're kind of very strict with this idea of 5 days on duty, 2 off, 5 on duty, 2 off, right? And they're considering what about being a little bit more flexible. This would be a schedule with days off that are not consecutive. Your days off will be a Tuesday and a Sunday. And because of that, which is some sort of an inconvenience, they would be willing to pay, a little more than the standard $1,000 a week. They would be willing to pay $1,200. Should this be advertised as a job at the restaurant, right? Meaning, would having a job like this help the restaurant in the sense that they could still staff the place, but overall spend less money on wages, right? Would this reduce or increase the wage expense? Let's take a look. Well, this is basically the introduction of a new variable, which means to check whether or not a new variable is beneficial to your problem, we're going to do that calculation of the reduced cost. And the thing I keep emphasizing is to do this calculation. What you typically should do is go and look at your math and find where in your math would this new variable appear and what would be the numbers appearing in front of it in each of your constraints. Well, we could introduce a column here, right, to represent this new variable. And this could be this work week type 8. And just like we have the ones here where people are on duty and off duty, let's find out where this person 8 would be on duty. Well, they say the off days are Tuesday and Sunday, right? So they would be on duty all the other days. You work Monday, not Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday they're off. So if we were to write the math, this x8 variable would appear with a 1 in front of it in the Monday constraint, Wednesday, Thursday, Friday, and Saturday, also with a 1, and wouldn't appear in the Sunday. Now to calculate the reduced cost, right, of x8, if you remember how the formula goes, you begin with the salary, right? So that is the number that would appear multiplying the variable and the objective, because it's $1,200 and our objective in thousands of dollars. We do 1.2, and you do minus what? Now comes a product. You'd go through every constraint the variable shows up in, take the number in front of the variable in that constraint, multiply that by the shadow price of that constraint. So before I finish this formula, let me paste those shadow prices over here, so I can take the shadow prices of every constraint, copy that over, I'm going to paste them here, right? And now I can do the reduced cost calculation for x8, which is the 1.2 minus the sum product between that column and the shadow prices. And I get this value. Now the question is, what does this mean, right? Is it beneficial to have this type of work week or not? Well, let's think about what problem we're trying to solve. Is this a minimization or a maximization problem? It's a minimization because we're dealing with cost. What does the reduced cost represent? It's the impact to the objective function value of using that variable. Well, if using x8 causes a negative impact on my objective, it makes my objective go down. Do I like that or not? Yes, I do, because I'm minimizing, right? So a negative reduced cost variable is a good variable in a minimization problem. That is, if you had this job, right, in your restaurant, you would end up saving money, because the way it would allow you to allocate overall fewer people, or actually spend less money in wages, and still meet all of these requirements here. Okay. Now let's say, so you're offering this at $1,200. Let's say you put this job out, you advertise for it, and then someone comes up and says, "Oh, I'm interested in that job, but can you pay, $1,350 instead of $1,200?" What would you say? Well, when I did this calculation here, I found out this job is beneficial because the number was negative. And I used a salary of $1,200. If this person is asking me for $1,350, right, will be this. And if I do that calculation, now it's a positive. So that's not beneficial to me. So my question to you is, what would be the highest salary you would pay for this position? Well, if I simply calculate this part here without the beginning, okay, this is the negative of this, right? It would be the maximum salary you would pay, so that you still get a negative result. So if you paid $1,333.33, this would be a break-even, right, result, because it will be that number minus itself equals 0. So this person neither helps nor hurts. So you could counter offer and say, well, the most I can pay is, pick a number that is less than 1,333.33 cents. Okay, so the reduced cost allows you to do things like these counter offers for situations like that. All right, great. So this is the end of this example. I hope it was helpful and it was useful for you to practice further the use of the concepts of shadow prices and reduced cost, and work with those sensitivity tables. Thank you guys for watching as always, and I hope to see you back here for more videos. Bye bye.